Heat transfer is the transfer of thermal energy from one medium to another.
My name is Santiago Camargo. Today I'll be explaining to you the subtopic of conduction, which falls under heat transfer. As we said before, heat transfer is the transfer of thermal energy between two different objects. The hotter one transfers to the cooler one until they're both the same temperature. Transfer by conduction happens in between contact, so between a solid and a fluid, which is a liquid or a gas, or between two fluids or between two solids. So usually, actually all the time, heat transfers from the hotter object to the cooler object. And between transfer for two different fluids, we use the example of a heat exchanger, which is this right over here. Usually heat exchangers are used when trying to cool or heat an object, a liquid, but it cannot come in contact with another liquid. So usually the cooler object will be on this side, the cooler liquid will be on this side, and the hotter liquid will be on this side, and they'll be separated by a wall, and the heat exchanger would transfer the heat until they're both the same temperature. Another example of heat exchange is when exchanging heat between two different solids. I'm going to give the example of a stove. So a stove heats up by itself, then it'll heat up the pan, which is made out of metal. As I said before, it's a really good conductor of heat. And the metal will heat up your food. So this is an example of heat transfer between two different solids. It is the best type of conduction, and obviously the greater the heat, the faster it will go, and the smaller the surface area, really the less heat you need to get to your desired temperature. Now, the pace that the thermal molecules move at is really dependent on different factors, such as the material. Like metal is a better conductor than plastic, and things like surface area, which can all be put into Fourier's law, which says that Q is equal to U A dt. U is K over S, it's the coefficient of heat transfer, and there are different things. This is the physics principle of it. We can ask you to, for example, the problem could have given you the heat exchange value, the coefficient, and the difference of temperature gradient, and you could have been asked to find the surface area that it was transferred at in meters squared. Keep in mind all of these are SI units to keep the basics going, I guess, and that is conduction.
Okay, my name is Kelly Zoe, and I will be talking about our second subtopic under heat transfer, which is heat transfer by convection. So I wanted to talk about what convection is. So convection is defined as the mass movement of a gas or a liquid. It can be either or. And it's heated and it transfers energy along with it. And so the example that I will be discussing today is a hot air balloon. And so just kind of explaining how convection lifts a hot air balloon, I want to point out this equation, which is known as the equation of state. And this relates these four variables right here, and this equation right here. And it relates pressure, density, R, which is the gas constant, and temperature. And I wanted to point out this equation because it relates our two main variables, density and temperature. And it shows here that density is inversely proportional to temperature. So if you higher temperature, then you lower density. And I want to make sure that that's in your mind. So explaining how convection works in a hot air balloon, the hot air balloon has the basket and then it has a burner beneath the envelope, and the envelope is like the balloon part. And the burner will heat up the air which is inside the balloon. And now this heated air gains kinetic energy because kinetic energy is kind of proportional to temperature. So you have an increase in temperature, which means you have a decrease in density. So inside the hot air balloon, the density of the warm air is lower than the surrounding cool air. And this is known as the Archimedes principle, which states that the lifting force of an object is when it's surrounded by another fluid or medium is equal to the weight of the object. So it creates the lower density of the warm air creates a lifting force or buoyancy force that allows the balloon to be lifted up. And so this lower density inside the balloon is less than the surrounding cold air. So the balloon is able to be lifted up until it reaches a point where in the atmosphere where the temperature of the air that's inside the pocket of the balloon is equal to the temperature of the surrounding air. So as you increase in altitude in the atmosphere, the temperature of the surrounding air becomes higher because it increases in kinetic energy. And the inside of the balloon, the temperature becomes lower than what is surrounding. So the density is greater inside the balloon, which means that the balloon is now heavier than the surrounding air, which causes the balloon to lower itself, and that's how you get lower. Yeah, that's convection.
Thermal radiation is when heat is transferred from a source to the surrounding medium in the form of electromagnetic waves. An electromagnetic wave is an oscillating electric and magnetic wave that travels through space at 299,792,458 meters per second, the speed of light. Everything takes in and gives off energy in the form of radiation. Transfer of heat through radiation occurs when the net energy change between an object and the surrounding medium is not zero. When the surrounding area is of a different temperature than the object, the net energy change is greater than zero, and heat transfer by radiation occurs. Hotter objects give off more energy to their surroundings, and cooler objects absorb more energy from their surrounding. According to Stefan Boltzmann law of radiation, Q is heat transferred, T is the temperature in Kelvin, A is the area, and T is the time, and E is the emissivity. The Stefan Boltzmann law of radiation can tell us the value of the energy change or the amount of energy radiated from the object to its surrounding. This equation can also be used to calculate the amount of energy absorbed. The net energy change of a system can be calculated using the following equation. The net energy change is the change in radiated energy between the amount of energy radiated from the source minus the amount of energy absorbed by the surrounding environment. This principle of heat transfer can be observed in a lamp. A lamp is a device used for giving off light, but it also radiates heat. A lamp contains a light bulb, which is the source of the heat that it radiates. When the electricity flows through the filament in the incandescent light bulb, the kinetic energy of electrons that pass through the filament generates heat. The heat produced by the electrons' kinetic energy caused by temperature of the light bulb to rise. This causes of net energy change to rise, and it becomes greater than zero. The light bulb, since it is now hotter than its environment, it will radiate heat to the surrounding atmosphere.